In the infinite expanse of the cosmos, a lone spacecraft drifts silently, a relic of humanity's ambition cast into the void. For nearly half a century, Voyager 2 has wandered through the abyss, its golden record whispering humanity's story to the stars. Launched in 1977, it was meant to explore the outer planets, a fleeting visitor to Jupiter, Saturn, Uranus, and Neptune. But its mission stretched far beyond, carrying it into the uncharted depths of interstellar space. Most believed its story had faded into a quiet legacy, a symbol of a bygone era when humanity dared to reach beyond its cradle. That all changed in 2023 when Voyager 2 sent a transmission that shook the foundations of science. It wasn't just data, it wasn't just numbers, it was a signal, structured, deliberate, and impossibly precise. A warning from the edge of the solar system that humanity had crossed a line it didn't even know existed. The universe, it turns out, might not be as empty as we thought. And now, something out there knows we're here. Voyager 2 was never built for this. Designed for a 5-year mission, it has defied all odds, enduring 48 years of cosmic radiation, micrometeoroid impacts, and temperatures hovering near absolute zero. Its power supply, a decaying plutonium core, is now a faint flicker, producing barely enough energy to keep its instruments humming. Yet, against all expectations, it continues to send data back to Earth from over 12 billion miles away, a distance so vast that light itself takes 18 hours to bridge the gap. In August 2023, as it drifted beyond the heliopause, the boundary where the sun's influence fades into the interstellar void, Voyager 2 detected something extraordinary. Its plasma wave science instrument recorded a sudden, violent spike in particle density, not a gradual shift, as scientists had predicted, but an abrupt wall of energy. The data was unmistakable. The spacecraft had crossed a threshold, a cosmic demarcation, so sharp it was as if the universe itself had drawn a line in the stars. But it wasn't the plasma readings that sent chills through mission control. It was what came next. A low-frequency hum, embedded in the carrier wave, repeating in a pattern too regular to be random, too complex to be noise. This was no natural phenomenon, it was something else entirely. The heliopause was always thought to be a diffuse boundary, a region where the solar wind slows and merges with the interstellar medium. Textbooks described it as a turbulent, chaotic zone, a gradual fading of the sun's protective bubble. Voyager 2's data obliterated that assumption. The transition was not a fade, but a snap, a sudden leap in cosmic ray intensity and magnetic field strength. In a matter of hours, the spacecraft went from the familiar embrace of the heliosphere to a realm dominated by galactic forces, where cosmic rays surged by 80%, and the temperature of the surrounding plasma jumped inexplicably. This wasn't just a change in environment, it was a crossing into a new domain, as if Voyager had passed through an invisible membrane separating our solar system from the rest of the galaxy. The magnetometer aboard the spacecraft recorded something even more unsettling. The sun's magnetic field, which should have been tangled and misaligned with the interstellar field, was instead perfectly synchronized, aligned with a precision that defies statistical probability. This wasn't chaos, this was order. And order in the vast randomness of the cosmos implies intent. The signal itself was the true enigma, buried in Voyager 2's telemetry, faint but undeniable, was a rhythmic modulation in the background carrier wave. At first, engineers dismissed it as interference, a glitch in the aging spacecraft systems. But as they analyzed the data, a pattern emerged. The signal pulsed at intervals that mirrored mathematical constants, ratios tied to pi, the golden ratio, and even the Fibonacci sequence. These weren't arbitrary numbers. They were the building blocks of the universe, encoded in a transmission that began the moment Voyager crossed the heliopause. The pattern wasn't just structured, it was familiar. In a chilling coincidence, portions of the signal bore a structural resemblance to the Arecibo message, humanity's 1974 broadcast to the stars, a binary encoded snapshot of our existence sent toward the globular cluster M13. The resemblance wasn't exact, but it was close enough to raise a haunting question. Was this an echo of our own voice, or had something out there heard us and responded in kind? The implications were staggering. Scientists began to wonder if Voyager 2 had triggered some kind of cosmic tripwire. The heliopause, long thought to be a passive boundary, started to look more like a sensor, a barrier that registers when something or someone crosses it. The idea wasn't entirely new. Theoretical physicists had speculated for years about the possibility of a galactic network, a system of invisible markers that monitor the movements of advanced civilizations. But speculation is one thing. Data is another. Voyager 2's transmission suggested that the heliopause might not be a natural phenomenon at all, but a constructed threshold, a line drawn by an intelligence far beyond our own. The signal's precision, its mathematical elegance, hinted at a system designed to detect when a species becomes capable of leaving its star's domain. And if that's true, then Voyager 2 didn't just wander into interstellar space. It announced our presence to something waiting in the dark. The scientific community was blindsided. At NASA's Jet Propulsion Laboratory, the team monitoring Voyager 2 was quietly instructed to limit public statements. Scheduled press conferences were cancelled without explanation. Leaked internal communications revealed a growing unease among researchers, not just about the signal, but about what it implied. The Department of Defense, in an unprecedented move, classified a portion of Voyager 2's data, citing similarities to a 2003 incident involving the Mars Reconnaissance Orbiter, which had detected a similar structured signal before it was abruptly silenced. The connection was tenuous but troubling. Both signals shared a mathematical cadence, a kind of universal grammar that suggested they weren't isolated events. For the first time in its history, Voyager 2's data stream was encrypted, a decision that spoke volumes. This wasn't about protecting scientific discoveries, it was about controlling the narrative and the fear. As the data trickled out to independent researchers, a new theory began to take shape: the mirror hypothesis. According to this idea, the signal wasn't a message in the traditional sense, but a reflection, an automated response generated by a system designed to echo the identity of whatever crosses its path. Imagine a cosmic sonar, not bouncing back sound, but structure, logic, even intent. The signal's resemblance to the Arecibo message could mean that whatever Voyager encountered didn't create the pattern. It simply mirrored what humanity had already sent. This theory, while comforting in its simplicity, raised a more unsettling question. What kind of system could reflect a signal with such precision across billions of miles? And why would it do so? Some scientists speculated that the heliopause itself might be part of a larger network, a galactic web that records the signatures of civilizations bold enough to breach their stellar boundaries. If true, then Voyager 2 didn't just detect a signal, it activated something. The heliopause itself began to take on a new significance. Far from a static barrier, it appeared to be dynamic, almost alive. Data from Voyager 1, which crossed the heliopause in 2012, showed a slightly different boundary, located 119 astronomical units from the Sun, compared to Voyager 2's 121. The differences weren't just in distance, but in behavior. Voyager 1 encountered a smoother transition, while Voyager 2's crossing was abrupt, marked by intense bursts of cosmic rays and magnetic anomalies. Some astrophysicists propose that the heliopause isn't fixed but fluctuates, responding to solar activity, galactic currents, and perhaps even external influences. They began to describe it not as a shell, but as a membrane, a flexible boundary that pulses with the rhythms of the cosmos. This idea gained traction when researchers noticed that the heliopause's position seemed to shift in response to solar flares, as if it were reacting to the sun's mood. But the most disturbing possibility was that it might also react to us, or to Voyager's crossing. The signal's timing added another layer of mystery. It began, precisely, when Voyager 2 crossed the heliopause, not a second before or after. This wasn't a gradual build-up, but an instantaneous response, as if the spacecraft had tripped a switch. Researchers scoured the data for natural explanations, solar flares, magnetospheric disturbances, even a chance alignment with a distant pulsar. None held up. The signal's structure was too precise, its repetition too consistent. Some began to wonder if it was a kind of handshake, a protocol initiated by an intelligence that had been waiting for something to cross the threshold. Others speculated it was a warning, a signal designed to deter rather than invite. The idea of a cosmic firewall, a barrier that protects or isolates regions of space, gained traction. If such a system exists, then Voyager 2's crossing might have been the equivalent of knocking on a door we didn't know was there. The broader context of Voyager 2's discovery only deepened the mystery. In recent years, the James Webb Space Telescope has revealed galaxies forming far earlier than current models predict, suggesting the universe might be older or stranger than we thought. Fast radio bursts, those enigmatic pulses of energy from deep space, have also defied explanation, with some theories linking them to advanced technologies. Voyager 2's trajectory, when mapped against these bursts, showed an eerie alignment. Its exit point, from the heliosphere, coincided with a cluster of repeating fast radio bursts detected in 2022, originating from a region of space just 3 light-years away. The odds of this being a coincidence were vanishingly small. Some researchers began to wonder if these bursts weren't random, but part of a network, a galactic grid that tracks movement across cosmic boundaries. If Voyager 2 wandered into such a system, its signal might not be a message, but a log, a record of our species' first step into the interstellar void. The implications of this idea are profound. If the heliopause is part of a monitored network, then it's not just a physical boundary, but a cognitive one, a filter that separates civilizations based on their ability to perceive and navigate the cosmos. Quantum theorists have long speculated about the role of consciousness in the universe, suggesting that reality itself might be shaped by observation. What if the heliopause is more than a barrier? What if it's a test? The signal's mathematical structure, its eerie resemblance to our own transmissions, could indicate that it's designed to probe the intelligence of whatever crosses it. Voyager 2, carrying the golden record, a snapshot of humanity's music, languages, and aspirations, might have been scanned, its contents analyzed by a system that doesn't just detect technology, but intent. The signal could be a response not to the spacecraft's instruments, but to the record itself, a recognition that the beings who sent it are capable of dreaming beyond their world. The stakes grew even higher when researchers noticed something else in the data. The signal wasn't constant. It pulsed in cycles that seemed to correspond to the Sun's 11-year solar cycle, as if it were attuned to the rhythms of our star. This raised a chilling possibility. Whatever generated the signal might not be located at the heliopause, but beyond it, using the boundary as a relay or a lens. The idea of a galactic observer, a system or intelligence that monitors the edges of stellar systems, began to take hold. If true, then Voyager 2 didn't just detect a signal, it triggered a response. The heliopause might be a checkpoint, a gate that opens only when a civilization proves itself capable of crossing it. And if that's the case, then humanity's first step into interstellar space wasn't a triumph, but a gamble, a move that announced our presence to something we're not prepared to meet. The scientific community, already reeling from the signal's implications, faced another shock when they revisited Voyager 2's earlier data. In the months leading up to its heliopause crossing, the spacecraft had recorded subtle anomalies, faint fluctuations in cosmic ray intensity and magnetic field strength. At the time, these were dismissed as noise, but in light of the 2023 transmission, they took on new significance. The fluctuations followed a pattern, a kind of prelude to the main signal, as if something had been tracking Voyager's approach long before it crossed the boundary. This suggested that the heliopause isn't just a reactive system, but a proactive one, capable of detecting objects well within the solar system. If true, then humanity has been under observation for years, perhaps decades, without ever realizing it. The idea of a cosmic observer sparked fierce debate. Some argued that the signal was a natural phenomenon, a quirk of plasma dynamics, or magnetic field interactions. But the more researchers studied it, the less plausible this seemed. The signal's structure was too precise, its timing too perfect. Others proposed that it was a relic of an ancient civilization, a beacon left behind to mark the boundaries of their domain. But this theory, too, faltered under scrutiny. The signal wasn't static. It evolved, adapting to Voyager's movements as if it were responding in real time. This left only one conclusion, as terrifying as it was inescapable. Whatever Voyager 2 encountered was active, aware, and possibly intelligent. The public, largely unaware of the signal's significance, began to catch wind of the mystery through leaks and speculation on platforms like X. Posts from anonymous researchers hinted at a cover-up, pointing to the sudden encryption of Voyager's data and the reassignment of key scientists. The lack of official statements only fueled the fire. Some claimed the signal was proof of extraterrestrial life, while others saw it as evidence of a cosmic phenomenon we're only beginning to understand. The truth, as always, lies in the grey space between. The signal's mathematical beauty, its eerie resemblance to our own transmissions, suggests something profound. It might not be a message from another species, but a reflection of our own existence, a mirror held up by the universe to show us what we are or what we're not ready to become. Theories about the signal's origin multiplied, each more unsettling than the last. One group of astrophysicists using AI-driven pattern recognition found that the signal structure bore similarities to quantum entanglement experiments conducted on Earth. In these experiments, particles separated by vast distances can influence each other instantaneously, defying the limits of space and time. Could the signal be a manifestation of a similar principle, a kind of cosmic entanglement that links the heliopause to something far beyond? If so, then Voyager 2 might have stumbled into a network that operates on principles we're only beginning to grasp, a system that doesn't just detect, but connects, weaving the fabric of the universe into a single, coherent whole. Another theory, rooted in multiverse cosmology, proposed an even stranger possibility. The heliopause, some argued, might not just separate our solar system from interstellar space, but our universe from another. The signal's mathematical precision, its alignment with universal constants, could indicate a boundary between realities, a seam where the laws of physics shift. Voyager 2, in crossing the heliopause, might have brushed against this seam, triggering a response from a system that exists outside our understanding of space and time. The idea sounds like science fiction, but it's grounded in the latest research, which suggests that the universe might be one of many, each separated by barriers we can't yet perceive. If true, then Voyager's signal wasn't a warning from another intelligence, but a ripple from another reality. A glimpse of a cosmos that operates on rules we can't imagine. The most haunting possibility, however, comes from the field of theoretical physics. Some researchers now believe that the heliopause might be a kind of information filter, a boundary that only allows civilizations with a certain level of understanding to pass. This idea draws on the concept of the Great Filter, a theoretical barrier that explains why we haven't encountered other intelligent life. What if the heliopause is part of that filter, a test of a species' ability to navigate the cosmos? Voyager 2, carrying humanity's aspirations in its golden record, might have been evaluated not by a being, but by a system that measures technological and cognitive maturity. The signal could be a verdict, a response that says, "You've crossed the line, but are you ready for what comes next?" The fact that the signal stopped as abruptly as it began only deepens the mystery. Did we pass the test, or did we fail? As Voyager 2 drifts further into interstellar space, its power dwindling with each passing day, the questions it has raised grow only more urgent. The spacecraft, now a silent sentinel, continues to transmit faint signals back to Earth, but none have matched the intensity or strangeness of the 2023 event. Scientists are left grappling with a paradox. The more they analyze the data, the less certain they become. The signal's mathematical elegance, its alignment with cosmic constants, and its eerie connection to our own transmissions suggest a universe that is not only structured, but purposeful. Yet its silence now is deafening, a reminder that we may have touched something we're not yet equipped to understand. The heliopause, once a footnote in astronomy textbooks, has become a symbol of humanity's limits. It's not just a boundary in space, but a threshold in knowledge, a line that separates what we know from what we fear. Voyager 2, in its quiet drift through the void, has carried us across that line. And what it found there wasn't a welcome, but a question. The signal, with its haunting precision, forces us to confront a possibility we've long avoided, that the universe is not an empty stage, but a watched one, a place where every step beyond our star is noted, measured, and judged. And now, as Voyager fades into the distance, we're left with a single, lingering thought. What happens when the watcher decides to respond?